Alright guys, so for the second half of 15.3, we're going to be looking at talking about percentiles. Okay, so this is going to be kind of like what we did with the first part in finding z-scores, except it's going to be working a little bit backwards. So our learning targets for this video is you should be able to use the z-table to determine the data value that represents a given percentile. Okay, and if you don't exactly understand what a percentile is, hopefully I clear it up for you here in the next few slides. The next thing you're going to be able to do is use a graphing calculator to determine the data value that represents a given percentile. So one is without, okay, so this first one is without a calculator. Let's redo that. Okay, so this first one is without calculator, and then this one is with a calculator. Okay, so let's figure out what a percentile even is. So perhaps you've heard before, maybe from a test score like an SAT or a PSAT, that you're in the 65th percentile for reading, for example. Well, a percentile is a data value in which a certain percentage is below the value in a normal distribution. So for example, if you're in the 65th percentile for reading, that means 65% of students scored below you on the test. So if you imagine on our normal distribution, okay, whatever the average was, that would be here. You scored somewhere over here such that this area below you is 65%. Okay, so 65% of people scored lower than you, which then means you can definitely use that the opposite way to say, well, then 35% scored above me. Okay, because ultimately these things have to add up to a total of 100% of your data. Next we have some examples. So you'll need your z-table for this, so make sure if you haven't grabbed a z-table that you grab a z-table from me. The average height for a man in the United States is 69.1 inches with a standard deviation of 2.9 inches. So if you imagine what our graph would look like, okay, right here in the middle would be 69.1, and I'd be counting by 2.9 out. So if you imagine 69.1 plus 2.9 is 72, and then if I subtract, let me get my calculator just to make sure I don't do this incorrectly. 69.1 minus 2.9 is 66.2, and if I minus 2.9 again, I get 63.3, and then 60.4. And if I go on the other way, I get 74.9 and 77.8. Okay, so we want to find the height that would represent the 75th percentile. So that means that 75% is below that height. So if you imagine right here in the middle, okay, right here in the middle, I already know that 50% is that way. Okay, so I need to figure out something in here, okay, some height in here, so that this area is 75%. So what I'm going to do is I'm going to use my z-table, and what I'm going to do is I'm actually going to look in the center of the z-table. So before we were looking along the edges, okay, so you were looking here and here for your z-score. Now what I'm going to do is I'm going to look in the center and find the number that is closest to 0.75, because that would represent the 75th percentile. So if you look around, okay, I have two values that are kind of close. I have 0.7486 or 0.75, where am I? 7517. Now, what you're going to do is you're going to pick the one that is closer to 0.75. So if you imagine this one is only 14 thousandths away, whereas this one is 17 thousandths away. So I am actually not going to choose that last one. I'm going to choose 0.746, and if you trace that out, what you're going to find is the corresponding z-score that you want to look at. So for me, that is 0.67. Okay, so I know that z has to equal 0.67. Okay, so if I use my equation, remember that z equals x minus mu over sigma. So 0.67 is what I just found my z-score to be, equals x minus my mu, or my mean, is 69.1 all over the standard deviation of 0.29. And so what I'm going to do, I'm trying to solve for this x value, because that will give me the height that is the 75th percentile. So I'm going to multiply this 2.9 over to the other side. So I take 0.67 times 2.9, and I get 1.943 equals x minus 69.1. Then I'm going to add this to the other side. So plus 69.1, and I get 71.043 inches would be my 75th percentile height. Okay, so again, that would be this height right here. That would represent 75% is below that height. Alright, if we apply the same logic to the second one, again, what I'm going to be looking for, I'm not going to rewrite all the numbers, but here at 69.1, okay, 50% of my data is this way. So I'm looking for something out here such that this area is equal to 25% of my data. So again, on my z table, I'm looking in the center for 0.25. Okay, and so notice this is going to be on your negative side, because I'm looking for something that is below the mean. So look on your negative side for 0.25. Let's see, what is close? I found one that is 0.2514 or 0.2483. Okay, and so to choose which one is closer, this one is 14 thousandths away. This one is 17 thousandths away. Okay, so I am going to choose this one because it is less. Okay, so if I choose that one and I trace it over to the left, I have negative 0.67. Okay, so again, that tells me that z is negative 0.67, which makes sense because if the 75th percentile was positive 0.67, then if I go the exact same distance to the left, it should be negative 0.67. So, again, using our equation, I get negative 0.67 equals x minus 69.1 all over 2.9. Okay, and so just like before, I take 2.9 times 0.67, and I get negative 1.943 equals x minus 69.1, and then add that to the other side. So negative 1.943 plus 69.1 is 67.157. So this is the height represented right here, that 25% of men are shorter than. Okay, as always, if this doesn't make sense, make sure you get my attention and ask questions. Okay, so that is how you would do it without a calculator. Now, if you do have a calculator, this is actually very simple. Okay, what you're going to do is you're going to hit the second vars, and since we are actually finding percentiles, okay, we're working backwards in the normal distribution, so we need to choose inverse normal. Because remember, when we were doing inverses, those are basically the opposite of what we were doing. So if we do inverse normal, so that's the third option, hit enter. Okay, the area, that is going to be your percentile. So you're going to go 0.75 in for the area. Mu is your mean, so that was 69.1. And sigma is standard deviation, that's 2.9. Going to hit enter. Enter again, and it spits out 71.056. Okay, notice that this is a little bit different than what we got without a calculator, but it is very close. Okay, very close, just the same thing. Okay, likewise, if you want to do the exact same thing, all you have to do is change the 0.75 to 0.25, hit enter, and you get 67.144. Okay, and again, if you're having trouble with your calculator and pressing the right buttons, make sure you stop me and ask questions. Okay, so revisiting the learning targets just like we always do. Okay, so you should be able to use the z-table to determine the data value that represents a percentile. Okay, that's again without calculators. And then same thing except with calculators. Okay, if you can do those things, then you are good to move on. I want you to move on to the finish your assignment. So finish section 15.3, then complete 15.3 assignment. As always, make sure you ask questions when you need me.